to the power of 3 equals 2. Then from here, we have x to the power of 6. We can have it as x to the power of 3, all in bracket, to the power of 2. Then minus x to the power of 3 equals 2. So let's take this to the other side. We have x to the power of 3, all in bracket, to the power of 2, minus x to the power of 3 minus 2 to be equals 0. Then from here, we can see that we have x to the power of 3 in common. We can say, let's x to the power of 3 to be equals y. Definitely we have here to be equals y to the power of 2 minus y minus 2 to be equals 0. Then let's do some manipulatives. Here we have y squared. When we have minus 2y plus y, minus 2y plus y will give us minus y. Then we have minus 2 to be equals 0. Now let us group this together as y squared minus 2y. Let's group this as y minus 2. Then we should let everything equal 0. From here, what is common is y. So we have y to the outside. Open the bracket. This y squared divided by this, we have only y. Minus 2y divided by this, we have only minus 2 left. Plus y minus 2 equals 0. Then from here, we can see that we have y minus 2. We can also factor that out as y minus 2 as this. Then we open another bracket. The whole of this divided by this y minus 2. We can see we have only y. Then plus this one divided by this, we have just only 1. Then we have to close the bracket. We should let everything equal 0. Now, it is obvious that for this expression to be equal 0, it's either we have y minus 2 equals 0, or we have y plus 1 to be equal 0. Now, what are we trying to say here? That from here, we have our y to be equals 2. Then let's go along with this first and see what will happen. Then mind you, from here, we have our y to be equals x to the power of 3. So definitely, we have x to the power of 3, x to the power of 3 to be equals 2. Then to get the value of x, we can take the cube root of both sides. So we have the cube root of x to the power of 3 equals the cube root of 2. So from here, this and this, we cancel this. We have our first solution as s to be equals cube root of 2. These are first real solution. Then we have to go along with this. When we have y plus 1 to be equal 0, but our y has been given to be equals s to the power of 3. So definitely, we are going to have here to be x to the power of 3 plus 1 will be equals 0. But mind you that we can have this as x to the power of 3 plus 1 to the power of 3 will give us 0. This 1 to the power of 3 is empty as 1, so we can have it as this. Now, let us recall from some of the 2 cube as, so now this one equals 0. Now from the sum, when you have a to the power of 3 plus b to the power of 3, this always equals as when you have a plus b as this, then multiply by a squared plus b squared minus ab as this. So which our a equals x, then our b equals 1. So definitely, we are going to have from here as x plus 1, because our a is x, our b is 1. Here will now be a square will now be x square minus our a will be x multiplied by our b is 1. We have minus x. Then our b square will now be plus 1 square will be 1. Then everything will be equal to 0. So from here, we can see we also have 1 plus x plus 1 to be equal to 0. And this implies that we have x to be equals minus 1. Another second resolution. Then from here, we have x squared minus x plus 1 to be equal 0. Then we can use quadratic formula as s will be equals minus b, positive or negative, root of b squared minus 4ac, then divided by 2a. Obviously, from here, our b equals minus 1, the coefficient of x. Then our a is the coefficient of x squared, which is 1. Our c constant is 1. So by plugging everything, we have our s to be equals. Here is already minus 1. Here will be 1. Positive or negative. Roots of minus 1 in bracket square minus 4 multiplied by a. 1 multiplied by c. 1. Then divided by 2 multiplied by a is 1. We have it to be 2. So we have s to be equals 1, positive or negative. Then roots of, here will be 1. Here will be 4 times 1 times 1 will be minus 4. Then divided by 2. This equals 1, positive or negative, root of minus 3 divided by 2. Then we have our s to be equals 1, positive or negative, with 3 multiplied by root of minus 1 divided by 2. But roots of minus 1 or equals I in complex number. So we have s to be equals 1, positive or negative, root of 3i, then divided by 2. Now, if you are to recall from the previous answer, we have sax1 to be equals cube root of 2. Then we have x2 to be equals minus 1. Then we are going to have our x3 to be equals, let's pick this 1, then let's go with plus root 3i divided by 2. Then let's go with x4 again, will be 1. Let's go with minus root 3i, then divided by 2. So now from here, we have 2 answers for this particular problem given to us. So we can check for the real solution, but not the complex solution. Though, when you check for the complex solution, you are going to have the same thing. But recall that we have x to the power of 6 minus x to the power of 3, then equals 2. Now, let us see if when s equals minus 1, whether we're going to have this. Now, to check, let's start from this. So, when s equals minus 1, we have minus 1 all in bracket to the power of 6, minus outside, minus 1 in bracket to the power of 3, then is it going to give us 2. Then, mind you that this 6 is even, and negative 1 in bracket to the power of even will give us positive 1, minus this negative 1 in bracket to the power of odd will give us negative. We have minus 1. then is it going to give us 2? Then 1 minus times minus will be plus 1, which equals 2. Here is 2, which is equivalent to 2. So this is true for the value of s equals minus 1. This. So definitely, when you check for this as well, we are going to have the same thing. We're going to have the same thing because we have it to be 2 to the power of 1 divided by 3, then to the power of 6 minus 2 to the power of 1 divided by 3 to the power of 3. Then is it going to give us 2? Then from here, 3 here 1, 3 in this we have 2. This 3 we cancel this 3. Then we have 2 in bracket to the power of 2 minus 2. Is it going to give us 2? From here, 2 to the power of 2 will be 4 minus 2, which is equivalent to 2. So 4 minus 2 is 2 equals to 2. So this is also true. This as well. You can check for this. Bye-bye.